A Beginner's Guide to Multimeters. A multimeter, also known as a multi-tester, is an electronic measuring instrument which can measure voltage, current, and resistance. It combines the functionalities of a voltmeter, ammeter, and an ohm meter into a single device. It's a very essential tool for electrical and electronics engineers, and is usually the first thing to use when troubleshooting a circuit. Multimeters come in different shapes, sizes, and price points. There are bench multimeters, handheld multimeters, and clamp meters. Basic multimeters are available from as little as $5, while certified and calibrated multimeters can cost up to $5,000. Irrespective of the size or price, every multimeter can measure the most basic parameters like voltage and current. In addition to this, modern digital multimeters, or DMMs, allow you to measure resistance and also test for continuity. Using a multimeter, you can check if a switch or push button is properly working, measure the amount of current flowing through a device like an LED, measure the voltage of an outlet, check if the wire is conducting electricity or not. A basic multimeter consists of 4 parts. They are the display, the selection knob, the ports, and the probes or leads. You can set the parameter to measure using the selection knob at the center. Some advanced and slightly costly multimeters can automatically adjust the range of the value being measured. These meters are known as auto-ranging multimeters, but in a basic meter you have to manually set the range. Usually every multimeter comes with a pair of probes, one red, one black. Connect the black probe to the COM or common port. The red probe is usually connected to the port with a positive symbol, or volts, ohms, milliamps. Now that we've seen a little bit about the multimeter and its parts, let us proceed to the main topic, how to use a multimeter to troubleshoot a circuit. First, I'll show you how to measure voltage using a multimeter. We will see the procedure for measuring DC and AC voltage. To measure a DC voltage like this battery, we'll select the DC voltage selection, which is usually signified by a solid line and a dotted line. We can see that this battery is 18.6 volts. Next, we'll measure AC volts. This selection is for AC voltage. It has a sine wave above it. We see 115.9 volts. Current is normally tested by opening a circuit, inserting the meter in the circuit. First, we'll move the positive pin over to the current input. This one has a 10 amp fuse. Second, we'll select DC current in amperes. Third step, remove part of the circuit, connect the meter in the center of the circuit, and we can see that this battery is charging at 1.07 amps. We can test AC current the same way. In this case, I'll remove the switch from this light socket, select the AC current setting with the sine wave. Make sure our probes are in the current configuration. And in this case, we're going to use the sharp ends of the probes to pierce the wire. We can see that this light bulb is using 0.03 amps. When we remove the meter, the circuit is open. One of the easiest things we can measure with a multimeter is resistance. For example, I'm going to use this dryer heater. In a heater like this, we have a high limit thermostat, a thermal fuse, and the heater coil itself. We can prove whether any of these components has failed using only the ohm scale. To start, we'll set our meter for resistance, signified by the ohm symbol. We can check the high limit thermostat, and we can see that it is just about shorted. That's a good sign for this thermostat. The thermal fuse on this unit had failed, but I have a spare. If we measure from one end to the other, we can see that it's reading almost a dead short. That's a good fuse. If we measure from end to end, we can see 47.6 ohms. If we measure from the center tap to the end, we can see 34 ohms. This heater has a high and a low setting, but both of those are properly within spec. Let's measure this drain pump and circulation pump using the resistance scale. You'll see that the drain pump will have a lower resistance because it's a higher horsepower motor than the circulation pump. If we measure the drain pump, we can see 20 ohms. If we measure the circulation pump, we can see 42. Most newer meters also have a continuity setting. You select it here. Whenever there's a completed circuit, you get a tone from the meter. We can check all these fuses and thermostats and coils without even looking over at the meter. Some meters, such as the Fluke 117, also has a non-contact voltmeter or volt alert. You bring the top of the meter near the wire and it will tell you if it's live.